Gentlemen, this is the nature of force and correlates with chapter 10.1 in your textbook. Your key concepts for this video are: what is force? How are forces described? How do we represent force in a model? And how do forces affect motion? So first off, when I say force, you might be thinking about Star Wars and Yoda and may the force be with you. But in science class, a force is simply a push or a pull. So when you're pushing against something, like a football player pushing and tackling another player, that's exerting a force. Or when you're pulling, like doing pull-ups or pulling on rubber bands, or the planets, the gravity is pulling on each other, pulling the two together, that's also a force. So force is simply push or pull. So how do we describe force? Force is described by two things. The first thing is its magnitude or its strength. So, for example, this foot kicking the soccer ball, it might have a force, a magnitude of 270 newtons. And, like velocity, it includes the direction. So in this case, its magnitude is 270 newtons, the direction is to the left. So the total force on this soccer ball is 270 newtons to the left. Force, like velocity, is a vector because it includes a number and a direction. You'll learn more about vectors in high school. So, how do we represent forces on a model? You'll see here there's a weightlifter and they're pulling the barbell up. And there's this long arrow here and a little arrow down. Arrows represent force. The length shows its magnitude and where it's heading shows its direction. So the longer the arrow, the greater the force. So this long red arrow has a greater magnitude than this little blue arrow. The red arrow is going up, the blue arrow is going down. So that's how we represent it on a model. Or on a car here, we've got lots of forces. You have the friction between the wheels and the ground. You have the force of the ground pushing up on the wheels, gravity pulling down on the car, the engine pulling the car forward, and air resistance pushing the car back. Lots of forces going on there. Lots of arrows. So how do we measure force? Its SI unit is the Newton, which you represent or abbreviate with a capital N. Yes, it is named after Sir Isaac Newton. We'll be talking about him more and his laws of motion soon. You can measure a Newton with a spring scale. You've also got fancy electronic ones. Basically, what it's measuring is it's measuring how much it takes to push 1 kilogram and accelerate it 1 meter per second squared. So 1 Newton is the equivalent of 1 kilogram times 1 meter per second squared. So now that we've talked about this, how do forces affect motion? We know in that equation, acceleration is part of this. Net force determines if and how an object is going to accelerate or move. Remember your 3 ways to accelerate: speed up, slow down, change direction. All movement is caused by force. Without force, nothing moves. And net force is simply the combination of all the forces on an object. There are 2 types of net force. We've got unbalanced net force, and we have balanced net force. Unbalanced net force is what happens when all of the forces together create a force in a certain direction. So here we've got 3 newtons pushing to the right, 5 newtons pushing to the right. So the net force, we take both of those, since they're heading in the same direction, we add them together, and our net force is 8 newtons to the right. In this other example here, we've got the box, 5 newtons to the left, 3 newtons to the right, so the net force, 3 of these newtons cancel out the 5 newtons there, we've got a net force of 2 newtons to the left. Notice how the arrow is smaller than the 8 newton one. So unbalanced forces cause acceleration or movement. In contrast, balanced forces do not cause any kind of movement. So 5 newtons to the left and 5 newtons to the right, they cancel each other out, and they create a net force of 0 with no acceleration. That's it. Be sure your notes have all the key concepts and vocabulary, and feel free to try this challenge question.